It's widely believed that the UK doesn't make anything anymore, and that British manufacturing is a relic of the past. But in actual fact, the UK remains one of the world's largest manufacturing nations, and while there may be far fewer steel mills and coal mines, Britain is spearheading the production of cutting-edge equipment, including spacecraft. I'm travelling across the country to meet some of the world's leading experts in space manufacturing, from family-run enterprises meticulously crafting ultra-precise gears to trailblazing space tech startups engineering state-of-the-art antennas. I'm meeting the people behind the businesses that have set their eyes on the stars, right here in the UK. My journey starts at Wrexham University spin-out Glyndor Innovations, who design and manufacture optical equipment for space telescopes. So when I think of research, I think of people sitting behind desks, but actually it's very hands-on here.
It is, but if you're developing processes and supporting people who are making things, then you really have to make things yourself, to understand the problem and to develop the solutions. So yes, it is very hands-on. It's quite industrial looking, if you look at the scale, they're 2 meters in size, some of the optics we make. So, you need cranes, you need pulleys, and all of the people need to be trained in these. But when it comes down to the testing and the analytical side, then you are crunching numbers at a desk and you are doing that. So it's both aspects, really.
It was fascinating to see mirrors and lenses being manufactured, but I wanted to know more about their application in space.
In this lab, what we've been doing over the last few years is we've been using the lab to first of all build up and then test a prototype hyperspectral instrument.
And what is a hyperspectral instrument?
If you look at the human eye, then you find that it's blind to a lot of the information, the spectral information that's going on around it. So this stuff is bouncing around, it's still in the sunlight, but the light is bouncing around our environment and we're just blind to it. That's okay for humans because we've evolved, we've got here. But if you're trying to do Earth observation, this light carries information that the light that we can see does not. And so what we can do with these kinds of cameras is we can look for the signatures of pollution, we can look for the signatures of health of crops, even health of, I don't know, the stuff you find on your supermarket in the vegetable racks. You can actually look at those with hyperspectral imaging to assess how close they are to deteriorating, to going mouldy. So all of this information is wrapped up in being able to look at the scene in sufficient wavelength detail as well as spatial detail in like the form.
I think the UK has a huge amount to offer for space, because we are high-end engineers. We produce high-end product, and as a nation, we've got the right environments for launch. We've got propulsion research. When all that comes together, and we have a very powerful position really on the global stage compared to the size of the UK versus the rest of the world. I think we are punching above our weight.
Space is a demanding industry that requires ceaseless innovation and a constant supply of new technologies. Thankfully, there's no shortage of British businesses who are willing to accept the challenge. In Huddersfield, West Yorkshire, engineering business Reliance Precision has been manufacturing mechanical components for over 100 years. I met with Head of Metrology David Torr to see how Reliance create the inner workings of spacecraft.
So to give you a bit of an idea of some of the stuff we make in this area, we just stopped by this here. This is what we reclass at Reliance as simple but difficult. It looks like a tin can. They don't look at like there's anything special on there. But actually when you're looking at the tolerances and the definition on the drawing, you've got 10 micron sizes, 10 micron concentricities, geometry's got to be round. It's very, very difficult to produce.
A micron, how big is a micron?
It's tiny.
Yeah.
So what we have, is, as if by magic, I have just by the side of me here, this is something we like to display in the business, just to let people realise and understand and remind them how big a micron is.
Yeah.
So you can see here, a paperclip is about 1,000 microns.
Yeah, wow.
So the diameter of a paperclip. If you look at something like a bacteria, 1 to 3 microns.
Yeah.
So sometimes we joke and say how many bacteria we're measuring today, because we're looking at a couple of microns sometimes. We're trying to measure within.
Yeah.
So very, very small.
Okay.
So you think the diameter of that has to be controlled within 10 bacteria.
Wow. And if it's outside of that range, it's not fit for purpose.
Correct, yeah.
Wow.
This product here is a hob gear, and actually this is quite a nice story behind this. When I started in 1999, my life at Reliance, we were developing this part, and this part is a bit that went on the Rosetta satellite that went out to the comet. So in 1999, we produced the part. I think 12 years later, it went into function. So it's quite a long time to work out whether the part's functioning correctly.
So the part didn't function until it arrived at its destination.
That's
Okay,
right.
so it's a long time to have your fingers crossed.
Absolutely, yes. There were a lot of happy people here when it worked perfectly fine. So yeah, that's made out of titanium. Some beautiful machining on there.
And so where would this have been in the Rosetta?
So it was for controlling the solar arrays.
Okay, so it's in some sort of gearbox to extend the solar panels out.
That's right, yeah.
Okay. Oh wow, and without the solar panels, it would have no power, so it's a very functional piece of equipment. I think one of the things that's most surprising is the difference in sizes between the business and history. So Reliance is over 100 years old, and they've been manufacturing since the 1920s. Whereas Oxford Space Systems, a young business set up about 10 years ago, they're both at the forefront of engineering. They've come from completely different time periods, but they're both working, in the same space ecosystem to create new space technologies. And without them, we wouldn't be able to make spacecraft here. I'm on the Harwell Science and Innovation campus to visit Oxford Space Systems and find out more about the deployable antennas they build here. Despite working within space-age facilities that wouldn't look out of place in a science fiction film, I was surprised to discover how Oxford Space Systems leveraged innovations from other more familiar industries.
What I do here is a little bit different than what others do here. So I'm from Denmark, where I studied fashion and textile design.
Okay.
So it's not the same as engineers, what they do here when they're working on their CAD models on the computer base. I'm very hands-on, and what I do is I work this beauty. So this is a fashion industry knitting machine, and we use it to make our satellites or antennas.
So you knit the antennas?
I knit the antennas.
Okay.
Yeah. So it's basically like the sweater you have on.
Yeah.
It's probably knitted on one of these. So for space, you can imagine there's not a lot of materials that can hold up into space. So we can't really use wool and cottons and the things that we are used to. But what we do use is a gold-plated yarn. So this is actually what we use. It is thinner than a single strand of hair. So you can imagine it is tremendously worrisome to work with.
And why this material specifically? Is it very strong? Is it durable?
Well, everything above. Mainly what we use it for is reflectivity. So you can imagine up there, if this is the knitted parabolic shape for an antenna, we do need it to reflect. We do need it to have that kind of dense structure, and we do need it to survive up in space because, it goes from very, very cold degrees to very, very hot all of a sudden, right?
Yeah, extreme temperatures.
Exactly.
Right.
So we take this yarn and it turns into this fabric.
Okay.
So this is just a small piece of it. And if you feel it, it's very textile, tactile.
Wow, yeah. It's beautiful. It's really
Yeah.
shimmery.
Yeah, and you can actually feel it's very stretchy as well.
Oh, yeah.
So that's very important for what we do here because we work with deployable antennas, right? So it has to go from a very small encapsulament to a very large structure. And this way, knit has that quality of it can stretch, but it goes back to its original shape.
Having visited a number of suppliers across the UK, I was keen to see where the various technologies and components come together. Airbus's manufacturing site in Stevenage is one of the locations where this takes place.
Do you still get excited to come into a clean room?
Always.
Yeah?
Absolutely. It never ceases to be an exciting place, you know. I mean, where else could you come to work and you go and see spacecraft being built and talk to the people that build it, really specialist technicians. So it's just great fun. It is just great fun. I think for the UK space industry, you know, it's been growing over many, many years. So I go back to when it was mostly sort of very science based with very large geo-telecom satellites. Now look at the diversity we've got. We've got a huge number of new startups, SMEs in the business, and they're all bringing new technology, new capabilities. So for us, we spend much more time engaging out with the sort of space ecosystem of new companies, understanding what's out there from a technology point of view. And sometimes our job is as a prime system integrator, is just integrating that technology into the spacecraft. On the spacecraft we're building and designing now, that's got the same digital switching capability as the whole of the UK's mobile phone network.
Just on the one
Just
satellite?
one satellite. So when we talk about these spacecraft that are going into orbit, we are talking about absolutely state-of-the-art digital switching capability to take up that weak signal that as it receives from Earth, change it, amplify it and send it back down, but on a multitude of different channels and different configurations. That's really exciting because the speed of the digital electronics, and you're putting it in an environment that is from a very, you know, one side of the spacecraft might be minus 150, the other side might be plus 150. It's in a higher radiation environment, and you're trying to keep that electronics working perfectly. That's the excitement.
So this is one of the components that Airbus manufactures.
Yes.
We visited Reliance Precision,
Yes.
who manufacture the gears
They do.
that are used in something like this. What exactly are we looking at?
So this is our solar array drive mechanism. So this is a component that is attached to the satellite and to the solar panels, and this will deploy the solar panels and make sure that they're facing towards the sun, and therefore you're getting power to the satellite.
Okay, it keeps them faced towards the direction of the sun,
Yes.
allowing them to charge a battery.
Exactly.
So
that.
without this, the satellite wouldn't have power, essentially.
Exactly, yep. It's the only product on site that there's no repair method. So for example, if one of the technicians was to unintentionally cut this wire short, there'd be no way of repairing that. Whereas if that was done on another product, you would be able to extend that wire. So basically, it's you get it right first time or the unit's scrapped.
The whole unit?
The whole unit.
Wow.
Yep.
So
Yep.
no pressure then?
There's a little bit of pressure on this, yeah.
So this is Perseus clean room. This is where like the final build for all propulsion happens.
And what does the propulsion system do on the spacecraft?
So it enables the satellite to fly, really, put it into its orbit and to put it to its full use.
Okay, and is this a propulsion system we're looking at here?
Yeah.
Yeah?
That's one of them.
Can we have a look at it?
Yeah, of course we can.
So describe this to me, like, what have we got here?
So this is METOP. This is, if you want to come around this side, you'll see a better image of it. So basically this is the whole propulsion system. So this is called an MPS sort of system. So it's a modular propulsion system. You've got an engine in the car, and this is basically a space engine, really. It pushes it into its orbit. It's got small thrusters. On this particular product, we've got 12 thrusters all in all, with one sort of main thruster. And with that, it can sort of tweak itself into its position, so it's very accurate.
One of the key takeaways from my journey is the collaborative spirit among these British companies. They're not just suppliers, they're partners in a shared vision to push the boundaries of what's possible. I was deeply struck by the enthusiasm and passion from everybody I met, including seasoned industry veterans and newcomers alike, all underscoring a shared dedication to advancing space technologies.
I think something that's really exciting about the UK in particular is it's got a really, really vibrant space ecosystem, especially with startups.
I came to study to the UK because I knew that the space sector in the UK is very big and it's
it's growing. I think it's a challenging industry to work in, but I think with those challenges comes so much job satisfaction from doing something where, you know, we're creating things that have never been done before.
I wouldn't do any other job in the world, to be honest. Every day is different as well, which is very important. Keeps you on your toes. I'm constantly learning off peers.
When you think that things you're working on, things you're building are actually out there and giving us the services that we need for day-to-day life now, it's an amazing place to be. Yeah, so it's fantastic.
The UK's manufacturing industry is not a relic of the past. It's a beacon of innovation for the future. And as we continue to explore new frontiers, it's these British businesses that will be at the forefront, pushing boundaries and ensuring that humanity's journey beyond our planet is not just a dream, but a reality.
I think it's an exciting time to be part of civil space in the UK. There's a lot going on, not only in terms of the robotics and AI, but also in the upstream, developing new hyperspectral technologies, for example, and really the UK stepping forward in the climate change actions that we have going on across the world. There's a lot of opportunities there, as well as the diverse supply chain that we've developed here in the UK. A lot of new innovation, a lot of creative ideas, a lot of novel ideas, which are really bringing forward civil space and making those futuristic ideas really seem like today's problem and not tomorrow's. If we look back 10 years, the things that we've achieved within the space sector seemed impossible. And now my role is really looking at the next 20 years of the space sector in the UK, and the ideas that we're coming up with just sound completely futuristic and impossible, but those are the things that we are working on, and we will get there.
Making the impossible possible.
Making the impossible possible.